Hey guys, in this video, we're going to see what an injective function is and how to prove a function is injective. And the example that we'll use is going to be very simple just so that you can see the structure. Let's start with the definition. So we define a function f mapping x to y to be injective if whenever f of a equals f of b implies that a equals b. So in other words, intuitively speaking, an injective function takes every point and it maps it to a different value. So no two points map to the same value. Now I have written it alternatively like this, and I will come back to this in a moment. But first, let me just show you a pictorial representation of an injective function. So over here, we have the domain, which is 3 points, and we have the range, which is 4 points. So your function maps these 3 points to 3 separate points. And that's the information we want to capture when we think of an injective function. And just to show you a non-example, consider something like this, where now you have these 2 points, they map to separate points, sure, but this point and this point, they both map to the same point over here. So this would be an example of a function that's not injective. So intuitively, we're just saying an injective function takes different points and maps them to different points. So the natural definition of an injective function should be the following. It should be saying that a not equal to b implies f of a not equal to f of b. And this is for all a and b in your domain X, assuming a and b are not equal, of course. Now the question is, why don't we take this as our definition of an injective function, and instead, why do we use this? Well, the answer is you want to think about what this statement is trying to prove and how you would actually go about proving a statement like this. So what you want to do is you have to show that for all a and b that are distinct in your domain, f of a does not equal f of b, for all a and b distinct. How would you do that exactly? Well, you could try and calculate f of a for an arbitrary a and f of b for an arbitrary b, but then how do you show that they're always different only when a and b are different? Well, one way to do it would be to think about, oh, okay, well, let's look at what happens if they're equal. And maybe we can figure out that all cases when they're equal actually are cases that we're not interested in. So you're essentially just proving the contrapositive of the statement anyway. So what you're saying is you're saying, okay, in order to prove this statement for all a and b, let's first examine what happens when f of a does equal f of b, and let's try to find some kind of contradiction to this statement. Well, usually what you'll end up finding is that this only happens when a equals b. So even though this is the more natural statement, this statement is the one that's easier to prove and more natural to prove, even though this is the more natural statement when you talk about an injective function. And that's why we have this as the definition of an injective function, even though it's equivalent to this following definition. And that's what I mean when I write the sentence. If you think about it, this is a strange statement to actually try and prove. So you might as well just prove the contrapositive, which is what we wrote above. And that's why this is the official definition. All right, so we saw this picture already. And keep in mind that even though this is the range of the function or the codomain, we don't always hit every point, but that's okay. In this case, we do hit every point, but since we have multiple points hitting the same point, our function is not injective. This would be an example of a surjective function though, because every point is hit. Now on to the example. And it's a simple example because like I said before, I just want to show you the structure first. And in a later video, we'll see a harder example. We want to prove that the function that maps integers to integers just by multiplying the integer by 2 is injective. So here's what you do. You just start with the first statement. Suppose that you have a and b in Z such that f of a equals f of b. You want to prove that this implies a equals b. So what does f of a and f of b equal? Well, that implies that 2a equals 2b because we're just writing what the function is. And then you just factor out the 2, so you're left with a equals b. And that's what you wanted to prove. So f is injective. And that's all. So if you found this video useful, hit the like button, subscribe to this channel. There will be weekly videos. And if you have some classmates who are also learning this subject, share it with them and hopefully it helps them as well. Thanks for watching.